All right, so the last section we're going to look at is on period change. And that's basically when you take a graph and you stretch it or you compress it horizontally. Okay? And we heard a little bit of what that sounds like. That has an effect on the pitch of the sound, right? If you're connecting this with like a sound wave. All right. So I'm just going to do something a little different here. So what does a period change look like? It looks like something like that. So two things we want to look for. The first thing is with a period change, the number that you're using is inside the parentheses. That's back the way it was the first day. Okay, so it's inside the parentheses. And the next thing you want to look for is the type of arithmetic you're doing. It's multiplication. Okay. Because it's inside, that's going to make it do something horizontal. And because it's multiplication, that's going to make it stretch or compress. So any transformation that has multiplication will always stretch or compress it. If it's inside, it'll do it horizontally. If it's out in the front, it would do it vertically. Okay. So these are all different examples of period changes. Let's try graphing sine x and sine 4x, and I want to see what the 4 actually does. I want to figure out, is that actually stretching it or is that compressing it? Okay. So what do you think the 4 is going to do? Stretch the graph out and make it like longer, or is it going to compress it? Yeah?
I would feel it's going to compress it.
Compress it? All right, let's try. We'll do zoom 7. Okay, so what that's doing is showing us the regular sine function. And in a second, you're going to see sine 4x.
Oh, compressed it.
It compressed it. Okay, so this transformation, it ends up being backwards. The bigger you make this number, you might think bigger number makes it bigger. No. Bigger number compresses it smaller. Okay, let's see how much smaller it actually got. Okay, let me do it on this page. Let's look at one cycle of the original. So that would be from here over to here. In that box, there's one cycle of the blue graph. Let's count how many we have of the red one. Okay, there's 1, there's 2, 3, 4. So by putting 4, like we did right there, it compressed the graph 4 times as much. If I put a 10 in there, you would get 10 cycles of the red one in that box. Okay, what do you think will happen if I do something like 0.5x? Yep, that's going to stretch it. So again, you might think, well, that's a small number. It's going to make it smaller. Nope, small number makes it longer, makes it bigger. So now if we graph it, the red, that's the original. The red graph is going to look stretched out. It's like we took the blue one and we stretched it horizontally bigger. Okay. So that would correspond to a lower frequency sound, stretching it out. Compressing it would be a higher pitch sound. And that's pretty much the only two things we're going to look at with this transformation. We're not going to have a negative in front of the beat. If we did, that would cause a reflection. We did look at a negative in front, but we're not going to do the negative inside. Okay. So the period change is going to stretch or compress the graph horizontally. So now, let's say we have this point right there. If I take this graph, take that point, and compress the graph horizontally. Well, I didn't draw it perfect, but that point squished way over to here. What part of the coordinate would have to change for that point to slide all the way to right there? Which part?
The x.
Yes, the x. Okay, so the x part of the coordinate is what's going to change today. That means the y part is not. Okay, so there's two cases. Either it's going to stretch or it's going to compress. If you put a number in front that's bigger than 1, that will cause the graph to compress. The bigger you make this number, the more compression you get. So it's the opposite of what you would think. As this gets bigger and bigger, the graph gets squished more and more. If you put in a number between 0 and 1, like 0.5, okay, any decimal between 0 and 1, that will cause the graph to stretch. Ouch. You okay? The closer that number gets to 0, the more of a stretch you get. You can't make it 0, because if you make it 0, that would wipe your whole wave out, and you just have a flat line. So it can't be 0. All right. So one thing that I am going to ask you, okay, and this is kind of like a question from yesterday, is when you stretch or compress it, you are changing the length of time it takes to do one full cycle. You're either stretching it or you're compressing it. I didn't draw that perfect, but we're going to want to figure out what is that new length from here to here, right? If you stretch or compress it. The way you figure out that new length is you take the original length, which is 2 pi, and you divide by the number that is in front of x. Right there. Okay. So to find the new length of a cycle, it's the amount of time it takes to start, go up, go down, and come back up. Take 2 pi and divide by b. Finding the length of the period doesn't require you to graph anything. It's kind of like finding the amplitude. When we found the amplitude of a function yesterday, we didn't have to graph. You don't have to graph anything. You just have to know what number you're looking at in the equation. All right, so let's try finding the period of some of these graphs. Okay, so no sketch required. Okay, so to find the period of sine 2x, the formula is 2 pi. It's always 2 pi. And then you divide by the number that's in front of the x. Okay. What number is in front of x here? 2. And what's going to cancel out there? The 2's. So you're left with pi. What that means is for this graph, in order to get one full cycle, you have to go from 0 to 3.14. That's one full cycle. Originally, you had to go from 0 to 2 pi to get a full cycle. So is this a shorter cycle or a longer cycle than the original? It's shorter. Yeah, in fact, it's half. So this graph has, the cycle of this graph has gotten shorter, which means the graph has been squished. Right, let's look at this one. Okay, before we do it, is this graph going to stretch or is it going to compress? That's going to compress. Okay. The cycle of this graph is going to be 5 times shorter than the original. All right. So my formula, t equals, let's see. What number always goes in the top of the fraction? 2 pi. And what number goes in the bottom? 5. That is the distance you would have to travel on the x-axis to see one full cycle. If you wanted to know what that is as a decimal, you can do it. You have to travel from 0 to 1.25, and you'll get a full cycle. You used to have to travel all the way to 6.28. Okay, that's the original cycle for every graph we did all week, or 2 pi. Okay, that's much shorter. It's much more compressed. All right, let's look at this one. Sine 1/4 x. Okay, is that graph going to compress or stretch?
Stretch.
Yeah, it's going to stretch. In fact, the cycle now is going to be 4 times bigger. That means you have to travel 4 times as far as you used to just to get one full cycle. It's going to be four times longer. So let's figure this one out. So 2 pi, and what are we going to divide by? 1/4. Now, instead of dividing by a fraction, you can instead multiply by the what? Reciprocal, which is, what's the reciprocal of 1/4? 4. That's why the cycle gets 4 times as long. So it's 2 pi divided by 1/4, but we're going to multiply by the reciprocal, and that's going to give me a length of how much? 8 pi. 8 pi. Okay, so what does that mean? Well, that means if you were graphing it, you would have to go all the way to 25.1 before you would see a full wave. It's much, much, much longer cycle. Okay. So any question on how to find the period if I give you a function like that? Now, what if I did that? So now I have a period change, and I'm shifting it up 3. What effect would the shift up 3 have on the period? Nothing. If your graph looks like that, and you take it and you move it up 3, it's still the same distance from here to here. There's no effect on the period. Okay. How about if I took that graph and I did like a vertical stretch to it? How does that affect the distance from here to here? It doesn't. No, stretching vertically does not affect that distance. How about if I took the graph and I move it over here to the right? That doesn't affect the distance from there to there either. So the only transformation that can affect the distance from there to there is putting a number in front of the x. That's it. All right, so how do we do the sketch? Well, first thing is we have to know what's going to change. We already said that. That's the x's. So that means the y's stay the same. Unfortunately, the y's are the easy numbers to work with. We don't get to work with those this time. Okay, so you're going to copy down the y's from the original table. So just as a reminder, what are your y values for sine? Yep.
0, 1, 0, negative 1, 0.
Yep, 0, 1, 0, negative 1, 0. And then your y values for cosine? Yep.
1, 0, negative 1, 0, 1.
Yep, 1, 0, negative 1, 0, 1. So those are going to be your y values, one of those 2 columns for every problem. Okay, x's. Well, x's are going to change. Let's look at this. Let's draw this just like that. Okay, let's take this graph and see if I can compress it. Oh, it's not letting me. Sometimes it doesn't let me distort it. Well, I know I had one on the other page that it was working for. Let me try this one. There we go. Okay. So what I want you to do is kind of keep your eye on this point right there. I'm going to stretch that graph out. Where did that point move when I stretched it? Stayed the same, right? Let me compress it. Where did that point move when I compressed it? Yeah, it stayed exactly the same. That point is at 0. Right? Think of your axis as being right there. No matter how you stretch or compress the graph, the first point is always going to stay at 0. And that's what I just tried to show you. If you take 0 and double it, it's still 0. If you take 0 and take half of it by compressing it, it's still 0. That doesn't change. Okay, so that's going to give us this point. The next point we want to find in our graph is this one. That's going to tell me where the wave ends. Okay. What do we call the distance from here to here? It's the what of the graph?
Period.
It's the period, right? So the way that we're going to figure out where this coordinate is, we just have to know how long that blue line is. That tells us exactly where this dot is going to be. Do we have a formula that gives us the length of the period? Yeah, what's the formula?
2 pi over b.
Yeah, it's 2 pi over b. So the 2 pi over b formula is going to give us the fifth coordinate, which I'm calling the one at the end. Okay, so that's the first coordinate. That's the fifth coordinate. So the fifth coordinate is at the very end of the cycle. And to find that, use the formula 2 pi over b. Now, the next one we want to get is right there. That's the third point. What's the connection between the third one and the first and the fifth one? Where's the third one located? It's right in the middle, right? How do you find, like if I gave you two numbers, like 10 and 20, how do you find the one that's in the middle?
I just subtract. That's what I usually do.
You what?
I usually just, I mean, it depends on the number, but I usually subtract.
You kind of subtract to do it? Well, what is right in the middle of 10 and 20? 15. What is 15? It's the what of 10 and 20?
Median.
In this case, it would be the median. It's also the, what else is it? Yeah?
Center.
Okay, so it is the center. I'm thinking of another word more like what we said before, though.
Average.
The average, yeah. So if you know the coordinate for the first point and you know the coordinate for the fifth point, if you average the two, you'll get what's exactly in the middle, and that's the third one. Yep. So the third coordinate, or the middle, is the average of the beginning and the end point. That's why you need to find the beginning and the end point first. Okay, so now, once you have the beginning, end, and the middle, now you can find the second point, right there. How do you think you would find the second coordinate in relation to the ones we already have? Yeah?
Average of 1.
Right. If you take the average of the first and the third, remember all the points are supposed to be equally spaced, and that's exactly what an average does. It keeps everything equally spaced right in the middle. So to find the second coordinate, what we're going to do is we're going to average the first coordinate with the third coordinate. Okay, so we start with 0. That's always going to be the same. 2 pi over b gives us the end. Average gives us the middle. Another average gives us the middle there. And now we have one more point we have to find. That's the fourth one. How do you think we're going to find the fourth one?
Average of 35.
Average of the third and the fifth. Yep. Now, of course, these are always going to have a nice pattern to them. So if you notice the pattern, you might not have to keep doing all these averages. Okay? You might start to notice, like if you had something like, say these were your x's, like 1.5, 2, 2.5, 3, you might be able to figure out the last one is 3.5 without actually doing an average because you notice the pattern. Right? So if at any point you notice the pattern, you can definitely just start using that. Okay. All right. So any questions on that? So you get the beginning, you get the end, and then everything else, average, average, average. If you don't notice the pattern. Okay. All right, so let's take a look at a few examples of a period change. We'll make the table, we'll do the sketch, and then we'll look at a few more different things we can do with sound frequencies. All right, so let's try this one. Sine 2x. All right, so now we know all the different transformations. Okay. Can anybody tell me what kind of transformation that one is? And I'm more interested in how you know that. Yep.
Period change.
Yep, that is a period change. It's a horizontal stretch or compression. And how do you know that?
It's a multiplication on the other side.
Exactly. The two things he said was perfect. It's multiplication, so that tells me right away that it's some type of stretch or compression. And it's inside. Inside tells me it's horizontal. Yep. Okay. So because we're stretching and compressing horizontally, what is not going to change in my table? The y's. Yeah, nothing's happening vertically. So what are my original y values for sine?
0, 1, 0, negative 1, 0.
Okay, so there's my y's. Off to the side, I'm going to put my original x's. Just for reference, I don't know if we're going to really, you know what, I actually don't think we're going to need the original x's when we do these. I know most of the time we do, but I think we're going to be able to use these steps that I gave you without. Okay. What did I say the first x value always is going to be?
0.
It's always going to be 0. Now, the reason that's true for the problems I'm giving you is because I am not combining transformations together. I'm never giving you a problem where you're going to have to say shift it left and stretch it. We're not doing multi-transformations. If you were, then I would have to modify these steps. These steps are specifically because I'm not doing multi-step problems. Okay, so first coordinate is 0. So now we know where we're going to start. What's the next coordinate we need to figure out?
The fifth one.
The fifth one. We got to figure out where to start and where to stop. Where you stop is at the end of one cycle. So that's the number that needs to go right there. How do we figure out where the cycle ends? Yep.
Do the period formula.
Yeah, and what's the formula for that?
T equals 2 pi over v.
2 pi over, in this case, it's 2. So this graph is going to end at pi. So I start at 0, I stop at pi. What's the next coordinate I figure out?
The third one.
The third one. And the relationship to the third one is it's right in the middle of the other two. What's exactly in the middle of 0 and pi? Pi over 2. So there's the middle. Now, we got to find the middle again and again. What's in the middle of 0 and pi over 2?
Wait, how did you find the middle one?
We average 0 and pi together. So we just add them up and divide by 2. So yeah, what's in the middle of 0 and pi over 2?
Pi over 4.
Pi over 4. Yep. And now this one, if you're not sure how to find it, just average the 2. Average means you add them together and then divide by 2. Now, dividing by 2 really means you're just taking how much of the number? You're taking half of it, yeah. So if you want to think of it as just taking half of it, that's fine. So add these together. And then when you're done, take half of it. That's how you do the average of those two. To add those two together, what do we have to make sure we have? Okay. What's the common denominator there? 2. So double the top, double the bottom. That has a denominator of 2. Now that does what would go in the top when we double what's in the top. 2 plus 2 pi. Okay. What's 1 pi over 2 plus 2 pi over 2?
3 pi.
3 pi over 2. And now, what's half of 3 pi over 2?
3 pi over 4.
3 pi over 4. We just multiply straight across. Now, if you would notice the pattern, you wouldn't have had to do the average this way. Okay, the pattern is this is 0 pi over 4, 1 pi over 4. Technically, that is 2 pi over 4, 3 pi over 4. And that one is 4 pi over 4. Once you reduce it, the pattern is harder to see. But that's the pattern. 1 pi over 4, 2, 3, 4. The next number would be 5 pi over 4, and 6 pi over 4. Okay. Any questions on how we got those x's? Okay. Now, are all of these x's equally spaced?
Yes.
Yes. If you wanted to think of it in degrees, it would be easier to see. That's 0, 45, 90, 135, 180. They're all 45 apart. Normally, they're all 90 apart. Okay, when we started out this week, they were all 90 apart. Because of that 2, now they're only half that apart. Instead of 90, they're 45. Okay, so now graph those points. Let's put 0, 1, negative 1. Let's label our x-axes with those values because they're all equally spaced. 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. I tried to say it again so you'd see the pattern, but you should reduce it when you read it. Okay, now plot your points. So we're right at the origin. Every problem today will start at the origin. Well, every problem today will start at 0 on the x-axis. Say it that way. Okay, pi over 4, we're at 1. Pi over 2, we're back down to 0. 3 pi over 4, negative 1. And then you're back to 0. Okay, that looks right. Now, every graph that I do today is going to look the same for sine. And every graph I do for cosine is going to look the same. How come they're not actually going to look stretched out when I do my chart? Yeah?
You're changing the values of the x.
Right, I'm changing my scale.
Scale.
Okay, because I'm changing my scale to fit the problem, my graph is always going to look like it's the same size. That avoids the issue. If you want me to stretch this 50 times as big, I don't have to draw it 50 times as big. I'll just change my scale. Okay. All right. Any questions on that one? Let's try this one. Cosine 1/4 x. Okay, so first question, what tells me that this is going to be some kind of stretch? That's all I want to know. How do I know that that's going to be a type of stretch? Yep.
Multiplication.
It's multiplication. Yeah. That's all that tells you that it's going to be a stretch. Now, what tells me it's going to be horizontal? It's inside. Yep. If it was outside in multiplication, like putting a number in front, that's a stretch, but it's vertical.
Isn't that what we did yesterday?
That's what we did yesterday.
Okay, sorry, just.
Okay, so we know it's going to stretch or compress horizontally, which means the what values stay the same?
Was.
The y's. What are my y's for cosine?
1, 0, negative 1, 0, 1.
1, 0, negative 1, 0, 1. Right there. And now my x's, we don't really need the originals because of the way I explained how to do it. Your first x value is always going to be 0 for the kind of problems, at least, that I'm giving you. We know where to start. Now we're going to figure out where to stop. What's the formula to calculate where we stop? 2 pi over b. What's b in this case?
1/4.
1/4. Now I think we did that earlier. Instead of dividing by a fraction, you do what?
Multiply by 4.
Multiply by the reciprocal, which is 4. So the graph starts at 0, and the cycle is going to end at 8 pi. Now, just to be clear, the graph doesn't stop at 8 pi. The graph goes forever. I'm saying the first cycle stops at 8 pi. Okay. So then where's the middle going to be?
4 pi.
4 pi. And the middle again?
2 pi.
2 pi. And the middle again?
6 pi.
6 pi. So when there's no fractions, this method works out pretty nice. Questions on the table? All right, now that has been stretched 4 times as much. Okay, this graph would look 4 times longer if I used the same scale. I'd also need a lot bigger piece of paper. So what I'm going to do is I'm going to change what my tick marks are. 0, 2 pi. From there to there, that's our normal graph right there. Okay. That's what we normally, if I was sketching the regular graph, that's the regular graph right there. It's little taller. But what we're sketching is one that's been stretched out 4 times as much, but I changed my scale, so I don't have to draw it 4 times as big. So it's 4 pi, 6 pi, 8 pi. So let's see, we're going to start at 1, 0, -1, 0, and back to 1. That's okay. I'm a little off. That's the idea. Okay. Any questions on that one? So remember, it was stretched 4 times as much, even though it does not look it. So let's look at this last one. So sine of pi over 2 x. All right. So it follows the same pattern as the last problems that we did. It's multiplication, and it is inside the parentheses, so it is going to stretch or compress horizontally. What column is going to stay the same?
Y.
The y. And what are my y values for sine?
0, 0, 1, 0, -1, 0.
Okay. So we got our y's. First x value is going to always be 0. So that should be an easy 6 points in the table right there. Now, what's my formula to figure out where the graph is going to stop? 2 pi over b. Now that's the same problem we had with 2 pi divided by a fourth. Instead of thinking of dividing by a fraction, we're going to multiply by what?
2 over pi.
2 over pi. Now we're going to multiply by the reciprocal. Okay, so instead of dividing by the fraction, we're going to multiply by the reciprocal. And what's going to happen when we multiply there? Pi's are going to cancel out. There's one in the top, one in the bottom. And what do we end up with? 4. So this graph is going to have a cycle of 4 units. It's the only graph we've ever done that the cycle is not going to have any pi's in it. So it might have looked like this was going to be a really bad problem at first because we had this awful number in front of x, but it actually turned out nice because the pi's canceled. So there's your cycle length. What's going to be the x coordinate of the middle? 2. And the second x coordinate?
1.
And the fourth one?
3.
3. So you don't even really have to average. Like you could take 4 plus 2 is 6, and then 6 divided by 2 is 3. But if you notice the pattern, it's faster. Okay. Any question on the table? All right. Now, this is the only graph this week that you could do without any labels on the axes. Technically, I want to go by ones on everything. Right? So if I'm going to go by ones, I don't need to put labels on my tick marks. Right? So let's grab it. So we got 0, 0, 1, 1. That's 2, 0, 3, -1, and 4, 0. There you go. There's your sketch. All right, any question on that? So that pretty much covers everything that's on the test for this week. Okay, so the 4 transformations, how to graph and make the table, and then how to find the period of a graph using 2 pi over b, and how to find the amplitude, which is what we did yesterday. That's everything that's on the test. Okay, so there aren't that many questions, but there are a lot of answers. I think there's 6 graphing questions, and each question for graphing has 11 answers, 1 sketch, and then 10 numbers in a table. So you can get partial credit for every number you get right or wrong in the table. So there's probably like 70-something answers on the test. All right. So homework will be the worksheet. Okay, same idea as the other 2 nights. It's on Schoology, and 5 questions. Tomorrow we will have a review day and go over anything that we need to before the test.